Hi, this is a brief presentation on electrical machines and their use in industrial power systems. The purpose of this presentation is to explain the basic functions of these devices and their uses. Electrical machines and transformers are vital in hard rock processing, so their advantages and disadvantages will be discussed using examples from this industry. The devices to be presented are transformers, induction machines, and synchronous machines. I will attempt to link the device's characteristics to specific industry examples and demonstrate how they make processing more efficient, cost-effective, and safe. Transformers transfer electrical energy from one AC circuit to another. They can be used to change the voltage of electricity flowing in the circuit. But why would voltage transformation be required? A classic example is distribution. Electricity is often consumed far away from where it is produced. Losses that occur as power is transmitted through wires exponentially increases when current is increased. Conversely, the losses can be reduced by increasing the voltage. Transformers are used to step up the voltage for transmission and then return it to a usable level at the other end. Changing voltage is also useful when measuring voltage or current. If an ammeter or voltmeter was connected directly to a high current or high voltage circuit, the meter would need to be massive to safely complete the measurement. Instead, transformers can change the voltage or current to a suitable level so reasonably sized instruments can accurately take the measurements. Transformers can also be used to manage harmonics, which cause excessive and unwanted heat in circuits. Electric machines transform electrical energy into mechanical energy in the case of motors, and the reverse is true for generators. Electric machines' primary components are the stator and the rotor. The stator is connected to the power supply for a motor. A balanced three-phase supply is connected to the windings physically positioned 120 degrees apart. This produces a three-phase flux in the stator and establishes a rotating magnetic field. This RMF interacts with the rotor and drives the motor. The opposite is true for generators. An external load moves the prime mover, which in turn rotates the rotor. The rotor interacts with the stator to create the RMF, which induces the current that outputs. Induction motors are inherently self-starting and do not require a permanent magnet, brushes, commutator rings, or position sensors. Squirrel cage rotors have two end rings that are interconnected by several bar conductors. In this arrangement, the rotor is a standalone winding and cannot be physically accessed to change the rotor current or phase to control the motor torque and speed. Slip ring rotors are similar in construction, but instead of bars, windings are used as conductors in the rotor. The windings are then connected to an external variable resistor so that the electrical characteristics of the rotor can be altered to control speed and torque. Synchronous machines work by magnetically linking the RMF and the rotor. The rotor can be magnetized by either permanent magnets or direct current applied to create an electromagnet in the rotor. In synchronous motors, the speed of the rotor and the stator's RMF are equal, regardless of load. Synchronous machines have no self-starting torque when operating as a motor and need a starting mechanism to work. On the other hand, when operated as a generator, they are self-starting. This contrasted behavior is due to the inertia of the rotor and prime mover and lack of inertia in the RMF of the stator. At an industrial application of an induction motor. Iron Bridge is a mine in the Pilbara that produces ore to extract magnetite. The raw material is extracted and needs to be refined. A key process of refinement is crushing and grinding. We will be looking at the induction motors and drives selected to power the high pressure grinding rollers that are part of this processing circuit. High pressure grinding rollers are used for size reduction of rocks and ores. They've been used in mining for the last 30 years. In large-scale mining operations, they are typically powered by two independent motors. Aside from iron ore, they are used in other hard rock processing, such as the Pillarguna lithium project currently being engineered by DRA. High-pressure grinding rollers consist of two counter-rotating rolls. Ore is fed from the hopper through a gap between the two rolls, where it is broken into finer pieces. Their popularity is increasing because of their lower energy consumption, their wearable components last longer, and they are simple to maintain. However, HPGRs are sensitive to material characteristics and the feed rate through the hopper, so fixed feed solutions limit their efficiency. Variable speed drives can be used to ensure the HPGRs are continuously operated with high throughput. Overall, they are essentially AC to AC converters. A three-phase AC with fixed magnitude and frequency supplied, and an AC with different magnitude and frequency is output. As electric motor's speed is frequency dependent, the drive allows the speed of connected motors to be controlled. Variable speed drives have several functional advantages. The load can be shared by each of the rollers, ensuring they wear at equal rates. If there is a change in ore characteristics, they have immediate roller response. Not only does this extend roller life, it also boosts yields by keeping the system at optimum point of operation. The drives are adept at finding and correcting faults without interrupting operations. They can detect events such as pulleys losing tractions or motors overloading. Left untreated, these events can cause damage to the equipment, so the VSD triggers a response to prevent damage before it occurs. The drive's control of torque, speed, and acceleration can avoid shock loading. Torque limits on the drive present fatigue failure of drivetrain and gearbox, and smooth starts at high torque reduce mechanical stress on gearbox and reduce roller damage. In summary, variable speed drives provide an elegant electrical solution to help a mechanical system work efficiently. Thank you.